which paper we are going to follow this for all the validations. So this is overall geometry. Material property, I will quickly show you. So basically one point I didn't explain earlier, because in my model, the workpiece where I want my heat source should start moving, that point is our origin, and that same origin we should keep here. Otherwise, what will happen? You will not see your laser beam. This is about assembly. Then in step, in theory, I told you this is highly strain rate phenomenon involving high strain rate, temperature. There will be material nonlinearity, contact nonlinearity. Okay, displacement, forces, temperature, status of the element, whether it is deleted or not. So all these you should check mark. Okay, output is it is not like that if you select extra output it will show error or something. Not. It is up to you. If somebody, I will tell you for what it will be used. All nodes will be all nodes of the work as well as two. So this node set will use for the initial condition definition to define temperature equal to room temperature for all the nodes. But other than that, RP we have just seen necessarily increase the computational time. So just choose the nodes in the machining zone so that it will create a contact between your workpiece surface and the tool surface. Now we'll see how this contact will look like when we see here. It is very easy. Just restrict other motions, give only one velocity. Okay. So this is one. For cutting, for workpiece, boundary condition will be very simple. That is fixing. Now we can see clearly. See when cutting tool will touch, stress generation will form. How it is looking, see. Here you can see the chip band is forming. In paper also it is shown. See, in this way, chip they took one point and analyzed that point, how stresses are changing. But it is something like this, where your band is creating, your chip band is creating. See, similarly like our simulation. Okay, for better thing, I will switch off the mesh so that clearly we can see. See. So this may be one of the result one can show in your paper. How chip formation is happening at the tool edge, and then once chip is formed, we know mode 2 will be active when the chip will slide over each other, and that we have given with the exponential softening. So see one band, the small flakes are separating, don't worry about it, because still abacus cannot handle all this high distortion and all. People still, these algorithms are still in the research, still in the development. They are making better and better to handle all this distortion and all this element handling which is fractured. So don't worry about it. We can selectively delete it if you want to get the result. Now see, this I want to show you. The chip are segmenting once it is sliding over the rect face. The main shearing is happening in this red area, but other thing that will be very clear if I will choose equivalent strain. See, the strain is very high at that region where the chip is going to slide. So this equivalent plastic strain value is going up to 4 or 5 maybe. So this is another result one can show in papers like this.